Hello and welcome to G.1 Lesson 2. This lesson is about determining the validity of a logical argument. Alright, so first off we have this word valid, validity. So what is a valid argument? Valid just means it can be proven with the laws of logic. So we're going to learn some logic laws in just a few minutes. And if one of those laws applies, then yep, we have a valid argument. This does not necessarily mean the same as true. So an argument can be valid without being true in real life. All right, so you may be wondering, what are these laws of logic? And there are three. The first one is called the law of syllogism. And here's a symbolic representation of it in this box over here. If we have two statements, so if we have P goes to Q and Q goes to R, we can always conclude, so that's what this means, therefore, P is going to go to R. So this might make more sense in words. So here's an example for you. Here's our first statement. If you are a student, then you go to school. So if you are a student, that's P, then you go to school. We're going to call that Q. So P goes to Q. All right. Then we have another sentence. If you go to school, so hey, look, that's the same as this one up here. So that's Q again. So Q goes to, so if you go to school, then you take math. That's something new. So we're going to give it a new letter. We're going to call it R. So check it out. We have the same setup here as the law of syllogism. P goes to Q, Q goes to R. So we should be able to conclude P goes to R. If we look at what P is, you are a student, and R is you take math. So that's how we get this conclusion. Therefore, if you are a student, so P, then you take math, and that's R. All right, here's another example of syllogism. If I go running, then I will be tired. So if I go running, we'll make that P, and then an arrow. So then I will be tired. That's something new. I'm going to call it Q. And then in our next little sentence here, we have if I am tired. So, oh, that's Q again. Then I will take a nap. That's something new. I'm going to call it R. So based on syllogism, we have P goes to Q, Q goes to R. Therefore, P should go to R. So let's see. So here we have, therefore, if I go running, so that's P, then I will take a nap. And I will take a nap, that's what we called R. So this is valid according to the law of syllogism. So, yay. Valid argument. And you'll get SOL questions that give you an argument and they say, is this valid? And so you have to remember what these laws say and see if it matches the same pattern. All right, here's the second law of logic. It's called detachment. And in the box, you can see the symbols of it. So again, we're starting with a statement, P goes to Q. And then they're saying, okay, hey, this first part is true. We have P is true. Then we can conclude, therefore, Q must be true as well. Here's how it looks. If a number is even, then it is divisible by 2. They're saying this is a true statement. So, okay, a number is even, we'll call that P. Then it is divisible by 2. That's something new, so we're going to call it Q. And then they tell us 4 is even. So that's about a number being even, which was our letter P. And by the law of detachment, if we have P, we should be able to conclude, therefore, Q is true. So we should be able to conclude that, hey, if 4 is even, it's got to be divisible by 2. And that, in fact, is our conclusion. Therefore, 4 is divisible by 2, and that was Q. Here's another example of detachment. If I go to the beach, then I will get sunburned. It is so true for me. So if I go to the beach, I'm going to call that P, arrow, Q is I will get sunburned. And then they're saying, okay, I go to the beach. So that's a true statement. I am going to the beach. So that's P. And we should be able to conclude, based on this detachment law, that I am going to get sunburned. Therefore, I get sunburned. That's Q. Notice how detachment does not work the other way. Like, if I said, hey, I got sunburned, we don't know for sure if I went to the beach or not. So it has to be P goes to Q, not the other way around. All right, we have one more law of logic, and it's called the law of contrapositive. So if you remember from the last video, the contrapositive is when we switch the order and add the not sign. We switch and negate. So that's what this law uses. So we say, okay, P goes to Q and Q goes to R, but therefore we're going to conclude that not R, the opposite of R, means that we have not P. So it's taking this last one here and this first one here. So not R goes to not P. Here's an example of that. If Jim gets paid, then he will go to the movies. So Jim getting paid, we're going to call that P. Then he will go to the movies. We're going to make the movies Q. He will go to the movies. Okay? Then it says if Jim goes to the movies, so that's Q again, then he will see Deadpool. That's a new idea, so we're going to call that R. So by the law of contrapositive, we should conclude that not R goes to not P. So what's not R? If R is we'll see Deadpool, not R would be he doesn't see Deadpool. And not P would be he doesn't get paid. So that's our conclusion. Therefore, if Jim did not see Deadpool, not R, then he did not get paid. So that's not P. One more example of the contrapositive one, this time with math. If a number is divisible by 4, then it is divisible by 2. So we'll make this first part P, like always, and the second part Q. So P goes to Q. And it says if a number is divisible by 2, so that's Q again, then it is even. New idea, so we're going to call that R. Based on the law of contrapositive, we can conclude then that if a number is not even, so that's not R, then it is not divisible by 4, so that's not P. See, we're kind of doing the opposite of the last one and the first one. Here's an example of the kind of question that you're going to get on the SOL. They're going to give you some statements and say, okay, which is a logical conclusion? What they mean by that is which one of these follows one of those laws that we learned. So I like to write them in symbols because that helps me tell what's happening. So this one says if a shape is a parallelogram, so there's P, then opposite angles are congruent, so that's Q. And then look at what they give us in the next line. They say a rhombus is a parallelogram. We already had something about a parallelogram, and that was P. So this is P again. So if we look at our little cheat sheet up here in these boxes with the laws, which one looks like the setup that we have? P goes to Q, and then P. That, to me, looks like this one right here, the law of detachment. And our conclusion in the law of detachment should be just Q. So if I look back at my example and see what was Q, Q says opposite angles are congruent. So I need to look for the answer choice that talks about opposite angles are congruent. And hey, check that out. Answer A says a rhombus has opposite angles that are congruent. So that is my correct answer. The last little thing with this logic stuff is the idea of a counterexample, and that's just an example that proves something wrong. So if you have a statement that's P going to Q, a counterexample would have the first part be true and the second part false. So here's what that can look like. If I had to write a counterexample to the statement, if you live in Virginia, then you live in Richmond. My counterexample needs to have this first part be true, so P needs to be true, and Q needs to be false. So I need to have someone that lives in Virginia, that is true, but then they don't live in Richmond. So here's a potential option, and you have a lot of different choices here. I said, well, I live in Virginia, so P is true, but I live in Ashland. So that means Q is false. I don't live in Richmond, I live in Ashland. So that is a counterexample that would prove this sentence wrong.